Creating a structure for analyzing results. Since this tree merges decision tree analysis, precision tree, with Monte Carlo simulation methodologies, at risk, its final results cannot be analyzed until a simulation has been run upon certain outputs of the model. We now need to define these outputs in order to be able to adequately analyze results right after a simulation has been run. The following table has to be filled in, making functions and links to the tree on the Params and Results tab, starting on row 16. Column B, prescribed, will show the outcome of 1 if a certain cell on the tree becomes true. The function, equals if tree B710, on B16 does that. You can copy this function down, being careful to edit and change the respective reference accordingly to all the decision and probabilistic nodes evaluated. For the contract consultant decision node, select cell B7, next, for nothing select cell C3. For chemical select cell C15. For organic, cell D11. For the weak chemical, cell D19. For the strong chemical, cell D25. For biocontrol, cell C35. For the ladybugs, cell D31. For conservation, cell D39, and finally, for the no consultant decision node, select cell B47. On cell C16 insert the following function that will calculate the mean outcome of every single node after the simulation has been executed, equals risk mean B16. Copy this function down for the whole range C16:C25. Column D calculates the value outcome of each node. Each one of these cells on the range D16:D25 should make a reference to the respective value node of the tree using the formula, equals tree C8. Fill this range accordingly. For the contract consultant node value, select cell C8. For nothing select cell D4. For chemical, cell D16. For organic, cell E12. For the weak chemical, cell E20. For the strong chemical, cell E26. For biocontrol, cell D36. For the ladybugs, cell E32. For conservation, cell E40. For no consultant, cell C48. Finally, for the value node of the whole tree, insert a reference function to B44 here. Column E calculates the simulated mean value of each node of the tree, percentage prescribed. Insert the function, equals risk mean D16 into cell E16, then, copy this cell down to the range E16:E26. After a simulation is run, this cell will indicate the value of each prescribed decision, assuming the decision maker is taking the prescribed tree path. By using the Add Output button on At Risks ribbon, declare each one of these B and D column cells as outputs. Notice that the reference to the output name between parentheses can be changed to column A. Columns B for prescribed and column D for value should now contain an output declaration. This is the way by which At Risk can later pick up collected information on such a cell after a simulation has been performed. Charts can be generated upon output functions. Statistic functions such as the risk mean functions can also be calculated upon previously declared output cells. Make sure that the precision tree model settings for its at-risk interface look as following. Each at-risk iteration calculates expected values of the model. The decision forcing settings during at-risk simulation are set to decisions may change each iteration, based on expected values. These settings are retrieved by clicking on the originating node, Pest Control, at cell A43 in the Tree tab. Make sure you have turned off the demo mode in order to run a faster simulation. Now, run a simulation with 10,000 iterations. Remember, at-risk will now interact with PrecisionTree to generate expected values at every single iteration being simulated. A different prescribed pathway may be generated depending on the damage function that quantifies the probabilistic impact of the pest damage. Wait until the end of the simulation. Once the simulation has been completed, we will be ready to interpret results on the next and final video.